Recorded! Yay!
This is for you.
Oh, thank you! Okay. Sorry about the dark glasses. These are my auxiliary glasses, so.
Okay. There it is. Come on.
Alright, right, homework 6 was usually just going through the book. I don't know the book, so. Do you have the problems with the questions? I hate having a parent form all over the place. Alright, assignment. Homework 6. Okay, consider the volleyball net shown. Oh, I remember this problem! Oh my gosh, I did this problem like 2 years ago! Yeah, it's so exciting! Oh my gosh!
I always struggling now.
Okay, determine the angle formed by guide wires A, B, and C. I totally did this problem! Okay, we have a volleyball net that looks like it. Where is it? Nope, don't think so. I'll check that. Well, honestly, it doesn't really matter what it is. It's a pole. It's one pole of a pole, but it's a pole. And we have coordinate system like this side. And we have guide wires. It goes out this white straight. Let's see. We got this is point A. Point C is like that. That. Here. And we have distances. That. Switch. 4. 6 foot. 6.5 foot. 2 foot. And this is 8 foot. Okay. And we are looking for the angle between B and C. Because we are going to follow theta. The first thing I always like to do whenever I get a problem like this is to make a chart of points. It's just keeping things neat and tidy. So we have X, Y, and Z coordinates, and we have points A, B, C, D. A coordinates 0, 0, 8. I'm going to draw an 8 and 0. 0, 0, 8. E is negative 6.5, y is 0, d is, I got this backwards. This should be 0, this should be 8. I have 2 so I think you can see it. At least I caught my mistake. Try to catch your mistakes. It makes things so much. Or better yet, don't make mistakes at all. Oh. And see, we have 0 in the x direction, 0 in the y direction, and 6 feet in the z direction. D, we have 4 feet in the x direction, 1 foot in the y direction, and 0 in the z direction. What this is really awesome for is making vectors. So the vector that goes from A to D, for example, well, the unit vector anyway. You need the unit vector, not the regular vector. I use these little hats, or these carrot hats for unit vectors. Equal to something over the square root of something times. Okay, and then we just take B and subtract from A. That's nice and easy. So we get 4. This should be 0, and this should be 1. Why do I keep doing that? 4, negative 8. No, this should be, yep, negative 8 and 1. So, if you're going to be writing out vectors, you need to stop and think about signs and make sure they're right. So what you do is you're going to imagine yourself at A, and you're going to walk towards the other point. And where do you need to go? Well, you need to go out a little on the x, so x should be positive. You need to go down, so y should be negative. And you need to go a little in the z direction, so z should be positive. Oh, okay. X is... Yeah, I know it follows the right-hand rule, but I'm used to being like this, and I'm having it like this. So, and this is going to be square root of 16, 64 plus 1, which is 81, which is 9, equal to 4 out of 9, negative 8 out of 9, 1. Of course, we didn't actually need D, because we're looking for B and C. But, you know, good to have it anyway. Oh. So, keep going. I am going to write these down so I don't forget them. Okay. And well, we do A, B. And A, B hat is negative 6.5, negative 8, 2 times 7. And once again, we're going to check our signs. Third A, walk towards B, we have to go back, we have to go down, we have to go a little bit out. So negative, negative, positive. Woo! Oh dear, that's a decimal point. That's 6.5 squared. 6.5 squared. 32.25 plus 64 plus 4. So we're going to add to that 68. And we're going to take the square root of that. Where is that button? 10.5. What a nice number. Got that. And now we're going to have a C hat, 0, negative 8, 6, because we're just walking, because we're not moving at all in the x direction, we're only moving in the z and the y. And we're going up in the z, down in the y. Times 1 over square root of 64 plus 36, which is equal to 100, 64 plus 36 is 100, times square root of 10. So it's 0, negative 4/5, 3/5. Hooray! And the question is, what is big? Well, how do we get big? Well, for one thing, we know that sine or cosine? I'm trying to do cross product. Okay, so AB plus BC, not BC, AB equal to the magnitude of A times the magnitude of B times the sine of theta. Alright, we're going to go with that, or we could just Google it. Yay, Google! What does Wikipedia say? Some data! Hooray! Okay. So, if we make these hats instead of arrows, then these become 1. So, in other words, the sine of theta is going to equal A, B, C hat. So, I like doing cross.
Is it AB plus A?
AB cross AC.
AC or?
Okay. I like doing cross product. So, the cross product is also the determinant of a matrix. And that matrix, I like to write it as I hat, J hat, K hat, which are unit vectors in X, Y, and Z, respectively. And we have to make sure we get the order right. So AB is negative 6.5 out of 10.5, negative 8 out of 10.5, and 2 out of 10.5. And AC is 0, negative 4/5, 3/5. And we want the determinant of that matrix, which we get to be okay. We cover that, we get negative 24 over 52.5 minus, oh, no, that's the plus, 8 over 52.5 and I. Wait. How is this happening? Because this is turning into a vector. We need a scalar. Okay, we need to actually do dot product. I messed up. So yeah, this isn't going to work. What we really need is dot product because this is going to do somewhere. Oops. Dot cosine theta, cosine theta. Okay. Right. We need to do the dot product because we do not want to end up with a vector right now. Oh man. Oops. Sorry. Okay. AB dot AC is much easier to do. Because we just look at these and we multiply. So that's the 0. That's nice. Oh, crap. Minus or plus?
Which one?
It's minus. I think no. This is what it's always positive, right? Okay, it is negative. Okay. Minus 32 over 52.5 plus 6 over 52.5 is going to give us 190, negative 26 over 52.5. So theta is which we don't have. It's cosine, that's an awful function. Maybe inverse cosine. Oh. We need, hold on, what do we get? Negative 26 out of, negative 26 out of 52.5 is that. Inverse sine of that is negative something radians, but we don't really care if it's negative or not because we're not in the arc plane. So we get 0.52 radians.
We need only radians.
Yeah, you only need it. I think we're doing a cosine inverse, so it doesn't matter if we do degrees or radians. So if we do it with degrees, and we do, again, we get negative 30 degrees, which is just 30 degrees. So, this is about 30. Hooray! Yeah. Well, I think it was a bit misleading. For starters, you don't need D. You don't even care if it's a volleyball. Basically, it's two vectors, and you need to find the angle between them. AC.
No, the ones you plot every in cosine or sine.
It's going to be cosine because if we do sine, that'll be a cross product. Cross product gives us a vector. We don't want a vector; we want a scalar.
Oh, okay. When we need a scalar, we use the cosine. When we need cross product, we need sine.
Yeah, cross to sine dot cosine. Vector cross scalar dot. It's so scalar cross product. We have sine and we get a vector. Use sine, get vector. And then dot you got three things. You got vector, scalars, and matrices. And you don't need matrices yet. Holy crap. Good. Like when you get into like 202 and 302, you get the stress in the thing is equal to stress is a matrix. Yeah, it is annoying. That stress, like when you bend something, it tends to break things when you bend them. That's how you tell when it's going to break. The sigma.
But it's not this thing.
Yep, not this class. Just telling you. Be glad you only have to work with vectors. You have a little bit of matrices. You need to find the determinant of matrices sometimes, but. Okay, that's problem one. Let's move on. Next problem is, yeah, these all look so familiar. Okay. This one, frame ACD is hinged at A, D, and is supported by a cable that passes through a ring at B. Hey, that was easy. Looks like I can't crop it though. Oh well. We just need this. Okay. And it's supported by a cable that passes through a ring. That looks like G and H. And all. Nope, can't zoom in. Okay. Where did I get this? Knowing that the tension cable is 450 newtons, determine the moment about the diagonal AD of force exerted on the frame by portion BH of the cable. Okay. So we have an axis. You have this axis. And we're going to take the moment about this axis caused by this vector point, which is tension, and tension is the same in all parts of the cord, because when you do is you cut the cord, it's the same here, same here. So tension is always the same. So we know that the magnitude of this vector, so BH is going to equal to BH hat times tension. And so next we just need to find BH hat. So point B is annoying. Okay, here 0.5, x direction. It should be a vector. 0 in the y direction. 0.75 in the z direction. And H is 0.875. Oh, here. These are kind of harder to make. Y is 0.7. 0. The vector going from B to H, unit vector anyway, is equal to 0.375, comma, 0.75, comma, negative 0.75. Alright, let's double check the signs. Start at B, walk towards H. We need to go a little bit in the X direction, positive. Definitely need to go up, positive. And we're going back.
That program is subtract. When that product will subtract.
Dot product.
Yeah, you just subtract from BH.
Well, we're not doing dot product, we're making a vector from those points.
Then what do we get? 0.37.
It's 0.875 minus 0.5.
Oh,
So, now we have that. Oh, wait. Times 1 over square root of 0.375. Square equals 2 times 0.75 squared. Oh, dear. What does it say? I wish I had a better calculator. Okay. Squared times 2 is 1.125. And 0.375 squared is that. We add to that 1.125 and we get, and we take square root of that. 1.125, that doesn't make any sense. And where is it? Square root. Yeah. Huh, weird. Okay. So then we get so we get 1/3 times 2/3 times negative 2/3. Probably should have just taken out 3/4. Yeah. Anyway, times the t, so we get that this vector is 400. 150, 300, negative 450 times 1/3, 2/3, negative 2/3.
400 times
450, right there, times 1/3 is 150, times 2/3 is 300, times negative 2/3 is negative.
Oh, because T is 400.
T is 450.
B 150 times.
Okay. Now we're going to do moments. Moment about an axis. Back to Wikipedia. Moment about axis. No, I'm just looking it up on the internet.
No. You like how you already explained. Use smart. That's what I'm saying.
Oh, thank you. Okay. Moment of force about a point. The moment of force about an axis in three-dimensional analysis. Calculate the moment and project that moment. Dot product. So we want R cross F. So what we want is this. Okay, yeah. It's the distance from the x, not the x. So what we need to find is this itty bitty tiny vector here. And I'm gonna draw this again a little bigger.